Okay, hello students. Today we'll take up the topic heights and distances. Clear? In this topic, we'll cover the first method to find the height of an object is the triangular method. This method is used to find the heights of the objects just like tree, building. Clear? Suppose AB is the height of the tree. That height is suppose h. Clear? What we'll do is from the base of the tree at certain known distance, that is say x, we'll measure the angle with the top of the tree, or you can say the building, with the help of the instrument known as sextant. Clear? This angle is suppose theta. Now how we'll find this height as we know the value of x, we know the value of theta with the help of the instrument, and we have to find the value of x. From this triangle ABC, we'll draw tan theta, that is equal to perpendicular over base, that is h by x. From here, if I take this x along this side, h will be equal to x tan of theta. If we know the values of x and theta, we can get the value of h. So in this way we can find the height of the tree, or you can say building. This method is known as triangular method. Next comes height of inaccessible object. Clear? In case of tree or the building, we can locate the center of the tree by measuring the perimeter or the building. Clear? But in case of mountain, we cannot locate the center of the mountain. So in this case, suppose we want to find the height of a mountain, which we suppose as h. Clear? AB is the mountain, its height is h. What we will do is randomly at any given point C, from where the top of the mountain is visible, we will measure the angle of the top of the mountain. This angle is suppose theta 1. We are supposing that we are unable to find the distance of the center of the mountain to the point of observation. This distance we cannot measure, that is CB distance we cannot measure. Clear? That's why this method is called inaccessible height method. Now what we will do is at certain known distance from point C, that is a point D, this distance is suppose x, we will again measure the angle with the top of the mountain, and that angle is suppose theta 2. Clear? What we are going to do is we have suppose the height of the mountain to be x. Randomly from any point we will measure the angle with the top of the mountain, that is theta 1. At a known distance from the C point, that is a D, distance is x, we again measure the angle with the top of the mountain, that is theta 2. Now from triangle A, B and C, from triangle ABC, we will measure the angle cot theta. Tan is perpendicular over base, cot is base over perpendicular. So in triangle ABC, base is BC and perpendicular is AB. Clear? So cot theta 1 will be BC upon AB, and AB we know that, we suppose that value to be h. Clear? So it will be BC upon h. If I take this h along this side, so BC will be equal to h cot of theta 1. This is your equation number 1. Now from the triangle ABD, again measure the cot theta 2 angle. In this case the angle is theta 2 with the top of the mountain. So cot of theta 2 will be again BD, that is B to D distance, base upon perpendicular, that is AB. We know the value of AB is again h, whereas the value of BD can be written as BC plus CD. BC is not known but CD is known, which is equal to x. Clear? So I will put up the values. From here BD will be equal to, taking this AB along this side, AB cot of theta 2, and AB is h. Clear? So BD will becomes equal to h cot of theta 2. Further BD can be written as BC plus CD, that is h cot of theta 2. BC from equation 1 over here, BC is h cot of theta 2. If I use this equation 2 over here at the place of BC, I will get h cot of theta 1 plus CD, which later on will put up the value as x, is equal to h cot of theta 2. Now if I take this h cot of theta 1 along this side to the h cot of theta 2, it will become CD, which is x, is equal to h cot of theta 2 minus h cot of theta 1. Taking h common, this will come out to be h cot of theta 2 minus cot theta 1, that will be the value of x. So further we can write this one as h is equal to x upon cot of theta 2 minus cot of theta 1. So if the values of x, theta 1 and theta 2 are known, we can find the value of the height of inaccessible object. Moving on to the next method to find the large distances, that is the diameter of moon. What we'll do is, we'll use the telescope over here. We have used sextant in the previous methods. In this case, we'll use the telescope. What we are going to do is, from the any point on the surface of Earth, we will focus the extremities. Points A and B are called extreme points. Extremities on the moon. We will measure the angle between these two extreme points with the help of the telescope on the surface of Earth. Let this point on the surface of Earth is O, and the two extreme points on the surface of the moon is A and B. And this angle comes out to be, say, theta 1 and theta 2. Or simply we can take this angle as theta. Clear? We suppose the diameter of the moon to be D, and the distance of the Earth from the moon is R. What we are going to do is, we will suppose this O point on the surface of Earth as a center, the distance between Earth and moon as the radius, and we'll draw a circle. Now of this circle of very large radius, the diameter of the moon will be arc, corresponding to the angle theta. We can directly apply the formula angle is equal to arc upon radius, where angle is theta 1 plus theta 2. Now theta 1 and theta 2 are the angles of the extreme points with the perpendicular drawn on the surface of Earth. Clear? For example, for point A, angle is theta 1, and for point B, angle is theta 2. The sum of these two angles is called theta, that is theta is equal to theta 1 plus theta 2. Angle is theta 1 plus theta 2, arc is D, that is the diameter, and radius is R. Clear? From here, D will be equal to R into theta 1 plus theta 2. As the values of R, theta 1 and theta 2 are known, we can find the value of diameter of moon. Next method is very important method, that is the parallax method. What exactly the parallax is? If we view the same object on the surface of Earth with our two different eyes, that is keeping one eye closed, see an object, and then keeping the other eye closed, see the same object. That object, on comparing the vision from the two different eyes separately, will observe there is an apparent shift in the position of the object. This is called parallax error. So we can define the parallax error as the apparent shift in the position of the object when it is viewed from the two different positions or locations. And it is used to measure the distances of the order of 100 light years. Clear? Now what in this case we will do? In this case we will suppose 2 points on the surface of Earth, first thing. Clear? And 1 point on the surface of that object for which we want to find the distance. So this method is basically used to find the distance of the distant objects from the surface of Earth. Clear? Now from the first point, say A, the angle with the vertical, or you can say perpendicular, to a given point or to any certain point on the surface of the object for which we have to measure the distance is, say, theta 1. सपोज अपने पास कोई स्टार है, कोई प्लैनेट है जिसका हमने डिस्टेंस अर्थ से फाइंड आउट करना है, उस पर कोई एक पॉइंट फोकस करेंगे और अर्थ से उस पॉइंट को फोकस करेंगे. क्लियर? एंड विद द हेल्प ऑफ टेलीस्कोप विल मेजर द एंगल विद द वर्टिकल. नाउ फ्रॉम द अदर पॉइंट again we will focus the same point and measure the angle with the vertical. That angle comes to be, say, theta 2. Clear? Now the distance between the 2 points on the surface of Earth will be known, that is, say, x, that is the distance between A and B is x, and that point, particular point which we are focusing from the surface of Earth is, suppose, O. Now what we are going to do is, from the object for which we have to find the distance, we'll suppose this O point to be the center of the circle. The distance of the object from the surface of Earth is, say, R, radius of circle, and we'll draw a circle like this. Now this AB point will be the arc of the circle. This theta 1 and theta 2 will be the angle, and this will be the radius, that is the distance of this object from the surface of Earth. Again applying the same formula, angle is equal to arc upon radius. Angle will be theta 1 plus theta 2, arc will be x, and radius is r. Now because we have to find the value of distance of the object from the Earth, we'll take this r along this side and theta 1 plus theta 2 along this side. So this will be x upon theta 1 plus theta 2. If the values of x, theta 1 and theta 2 are known, we can find the value of r. Now after this, moving on to the next methods, that is called echo method or reflection method. Suppose we want to find the distance of an object from a particular location. What we are going to do is, in the reflection method, we'll send the waves by the transmitter, for which we know the velocity of the waves are known, and we want to find the distance of the distance of the object from the transmitter. We'll send the waves from the transmitter which strikes the object and reflect back and received at the receiver. Again, this instrument which we are going to use to transmit and receive the waves will be able to measure the time duration in between when the rays are transmitted and received. That time is suppose t, and the distance of the object from the transmitter is suppose d. Clear? Now velocity, we know the formula. Velocity is equivalent to, or in this case you can say speed is equivalent to distance upon time. The distance covered is twice. एक बार t से o तक जाने के लिए, एक बार o से r तक आने के लिए. So distance will be 2d, time taken is t. We want to find the value of d, that is the distance of the object. So this will be v into t by 2. If the values of velocity of the wave and time period between the transmitting and receiving of the wave are known, we can find the distance of the object from the transmitter or receiver. Radar method is an application of echo method, in which we will find the height of the object and we can detect the object. Clear? So that's why radar is also known as radio detection and ranging. This radar is abbreviated as RA is taken from the radio, detection say D, A from and R from ranging. We use radio waves in this method because the attenuation of the radio waves, attenuation means loss of energy, while propagation of the radio waves in the atmosphere is least. Clear? Again, in the same method, we will transmit the waves from the transmitter which will reflect the flying object and receive back at the receiver. Suppose the height of the object is h. Again, we will use the same formula. Velocity is 2h by t, from where h will be equal to v into t by 2. You need to remember that the attenuation of radio waves are least. Then comes intensity method. What exactly the intensity method is? Intensity, we know that to measure the distance of any star from the surface of Earth, the light from the star is reaching on the surface of Earth, and intensity is inversely proportional to the square of distance of the star from the surface of Earth. So removing the proportionality, we will get the proportionality constant as k. Suppose first we'll take up the example of sun. Intensity of sun is a star, is equal to k, proportionality constant, upon distance of the sun from Earth, square of this. This is also known as astronomical unit. Now, any star for which we have to measure the distance, intensity of that star will also be equal to k upon distance of star square. If we divide these two, k will get cancelled out. We are left with intensity of sun upon intensity of star, distance of star square upon distance of sun from Earth square. Clear? We know the value of intensity of sun, distance of sun, and we will be knowing the value of intensity of star. So we can find the distance of star from the surface of Earth. This method is known as intensity method. Thank you. We'll take up the next topics in the next video. Stay safe, stay home.